Hi guys, today we're gonna start a new series called C++ 17 features, where in every video, I'm gonna explain a new feature in C++ with some examples. Um, I think the reason it's important to know C++ 17 features is because this will allow you to write more maintainable code, and in some cases more performant code, like the example that I'll show you today. So today we're gonna cover this feature called variant. Variant been in C++ before. It was in Boost, but it was recently added in the 17 feature as a standard feature. I don't think you should really know it because it will really allow you to write much more performant code. Okay, so let's go over the example. Let's say we want to write regular polymorphic class, right? Where we have a base class, then we have some derived classes, and we want to have a collection. We're going to go over through like that collection by using the base class interface, right? So this is a very simple example of a polymorphism, right? So let's say we have a class base that has a field called ID, then it has a simple constructor that initializes that field, and then it has this method called join, right? And it's a virtual method which our derived class will inherit and implement it, right? So then it has this other accessor method called getID, and of course virtual destructor. You should always have virtual destructor when you implement the polymorphic interfaces. Okay, so this is our derived class called other that derives from base. It has a similar constructor that basically just forwards the call to its constructor, and of course it overrides the parents class called join. So in the other case, join means just add the value, right? So I think simple enough. And then this is our second derived class called multiplier, which does the same thing that other does, except that in its join implementation, it multiplies the value, right? So multiplier and other just adds it, multiplier multiplies it, right? Let me quickly show you the base again. This is base, regular per virtual function, join. All right, all seems pretty simple, right? It's simple inheritance. Okay, so how do we go through this collection, right? This is the most common case. What we do, we have a collection of a shared pointer to class base, right? And then let's say we go over, I don't know, 10 million times, right? And we create, when it's even, we create other, and when it's odd, we create multiplier, right? And we just add it to our collection, right? This is a standard code. You probably wrote it many times. This is probably by the book way to write it. And so then let's say if you want to access it, that collection. So let's say we go through the collection, we just call join on it, right? So it uses the base class interface, calls the appropriate implementation. So everything is standard here. And then the last thing we want to do is we want to calculate the sum, right? I mean, of course, this is not the most efficient way to do it. We could have just, do the sum here. But for the example, just stay with me here. So we iterate again, calculate the sum, right? By going through all the elements. And then at the very end, we just print it, right? Okay, so now let's jump to our main, right? So the function called sharePointer. Let's run it, right? Let's see how long it takes. Okay, we're gonna build an optimized mode. So you have to make sure that you pass C++ 17. Actually, no, in this case it doesn't matter because we're not covering variant just yet. But it's not gonna. There you go. So now let's run it. See how long it takes. So this, I'm running it on MacBook. Here we go. This is our result, right? Don't really worry about the result itself because in this case we actually overflowed, but what else? So it took us 2 seconds, right? About 2.1 second, right, to run it. Let's run it second time just to make sure that everything is. I mean, my machine is not super powerful, but it's a regular MacBook of I think 2013 dual core. All right, so 2.1 second, right? This is what we got for using the sharePointer. So basically that's a by the book definition of doing it, right? So some of you might say, well, like you shouldn't use SharePoint, you should have used row pointers instead, right? That'll be faster because SharePoint has a reference counting, all that stuff, right? So I'm like, okay, let's, now I have the function called the row pointer. Let's see. Let me show you how I implement the row pointers. I mean, you really should never do that, But let's say for for whatever reason we wanna, in this case we wanna do the performance measurements, so it's probably a little bit faster. Okay, so yeah, we have a pointer to the base class. Then we do the same thing, if it's even, we add adder, then multiplier, right, if it's otherwise. Then we go through it again, modify it, and then lastly we try to get the sum, right? And then the very last step, we have to delete the values that we have, right? Because we have to clean up after ourselves, because we're using the row pointers, otherwise we're gonna have a memory leak. All right, so now let's compile again. Let's see. Oh, okay, so it looks like we got better, right? 1.7 seconds. Okay, maybe one more time. Okay, so the best one we have now is 1.7 seconds. Right, let's say that we want to go even further, right? We don't want to clean up, because in reality cleanup actually takes time. So let's say we want to comment out. This is already really bad code that at the beginning it was bad because we were already using row pointers, but this time we actually leak in memory. We're just trying to get the best performance possible, right? Let's say we don't care, our process just doesn't care if it leaks for whatever reason. Let's see. There you go. Okay. So now we got the 0.9. So about 880 milliseconds, right? 890. And that's given we are leaking, right? Let's say it's 900 milliseconds, and that's we already leaking at this point. The time that we had without leaking was the 1.7, right? So 1.7 is without leaking, and 900 milliseconds with leaking. So now let me show you if we can do better. In this picture comes a variant. So in order to use a variant, we have to include this header called include variant, right? Now, so the way you can think about variant is like a union, right, in C. So similar concept. So what we do is, we say, using variant type, we declare a new type, right? And we say, okay, this is going to be std variant, and then we can just list our types that we want to support, right? So we want to support adder and multiplier, right? We don't have to say anything about the base class, because it's already implies, right, through the inheritance. So now we have a collection of var types of the new type that we created, of our variant type. So what we can do is, now we do the same thing that we did in our previous examples where we go through it, right? And then we add this adder and multiply, right? The same way when it's even or odd. I could even optimize it further by using in place back, but at this case I wanted to have an apples to apples comparison, so let's just do the pushback, right? Okay, so now you remember how in our previous example, right, like let's say with the share pointer, in order to access it we can just call something like this, right? And that would use the base class interface and would just do what we're supposed to do. So in this case, when we use variant, we have to use this thing called visitor pattern. So we're going to use a visit. It's a std visit that comes also from variant header. So we don't have to create new header or anything, include a new header or anything. So now I hope you guys are familiar with lambdas. So what we do is we call this function called visit, right? And then we create this lambda. In this case, we capture I by value because we're gonna use it later on. And then we just write this simple lambda, right? Basically, what it does is takes an argument by reference, then calls a join on that argument. And that's it, right? Nothing interesting. And then there's a last argument to this visit pattern. We call visit function call. We send our actual variable, meaning our variant, right? So basically, the interface of the visit is your lambda, and then the object that you want to operate on. Okay, so it's pretty simple, right? In this case. So basically, let me just quickly visit this. You put the lambda here and the variable here, right? Like it's very simple interface. Okay, and then we go through it again. So in this case, we don't return anything, so it's very simple. In the second case, when we calculate the sum, we want to do the same visit, except that this time we want to return the value because we need to get the get ID, right? So we do similar thing where we create we call the function called the visit. Then we pass our lambda into it. In this case, we actually return the value. So yeah, we're doing everything by the book. We specify the return type. We call the return. I mean, very simple, right? Like there's nothing to mention. It's just a simple lambda, and then we pass the value into it, right? Okay, so this is how we calculate the sum, and then we display the sum. All right, so let's see how long does this run, right? And then explain you why it's so fast. I already told you. Okay, in this case it's 700 milliseconds. And in this case we don't have to clean up anything. It's already, everything is handled for us. Let me just quickly see variant. Did I? Yep, that looks good. Okay, yeah. So you see over here, everything is, there's no cleanup necessary, and it takes about 780 milliseconds only. While you remember our case with the even row pointers, when we were cleaning up, was what, 1.9 1.8 milliseconds, right? And without the cleanup, when we were looking memory, it was even, that was still slower than our case right now, right? And really, if you go further in terms of this time, like the number of iterations, if we go to, like, let's say billion or something, the case gets worse, right? I didn't want to go that far because for the length of this video, we don't want to make it too long. All right, so let me tell you why is it fast, right? I'm sure some of you already probably understood, right? So what happens is that when you use a variant, unlike SharePoint or row pointer, you don't have to allocate on a heap. You don't have to call new and stuff, right? Like everything is, you see, I just create the object and I just put it right away next to the I call it into value, right? So what happens is that when you iterate over, let's say in this case, for example, like in these two loops, right? When you iterate over the values, right? The case is variant, all the values are close to each other. They just copies in the vector, right? So when you go through the vector, it's all contiguous memory, and there's no problems there. When you use the share pointer or the row pointer, even though the pointers themselves are close to each other, but when you have to access them, the values that the pointers are pointing on, they could be anywhere, right? So if our objects were bigger, right, or if our use case was more realistic, right, in here we just like create everything in one shot, right, like close to each other. If our use case was like a real program, let's say some web server or something that was like creating values, those values get created on random time and stuff, so the memory gets more fragmented. The case for share pointer and the row pointer will be much worse. It'll be much slower than the variant. So this gets even worse, the performance for those types. That's why the using variant is actually way more efficient, and it's actually nicer to maintain, because you don't have to worry about memory or anything like that. So as you can see, this is very useful functionality. Okay, guys. I hope you like this video. If you like this video, please comment below, say if you want more videos like that for other features or not, or if I suck, just say you suck, stop making videos. All right, please, thank you.